Hello, welcome to section 8.1, the Pythagorean Theorem. This is probably a theorem you've heard before. It has to do with right triangles, so hopefully this lesson is a bit of a review. The essential question is to figure out what the Pythagorean theorem is and how we can use it to find the side lengths of a right triangle. So first, a little bit of a review. When we have a right triangle is again a triangle with a right angle, a 90-degree angle. When we have a right triangle, there are some names for the sides. The sides that connect to that 90 degrees, those are called legs. And the side that is across from the 90 is given a special name in a right triangle, and it is called the hypotenuse. All right. The Pythagorean theorem states that for any right triangle, a squared plus b squared is equal to c squared. All right. The important thing about a squared plus b squared equals c squared, the a and the b are always the legs of the triangle. The c is always the hypotenuse. It doesn't really matter if you put the b first or the a first. Whichever leg goes where is fine. But this c is the really important one. Make sure that you put the hypotenuse in that position. All right, so we're going to try a couple of example problems. First off, all right triangles. In all right triangles, a squared plus b squared is equal to c squared. So down here, we've got two triangles that look like they're right triangles. It looks like these angles are 90 degrees, but I don't know for sure if they are. So one way to check if a triangle is a right triangle is to just plug it into the Pythagorean theorem and see if it works. Again, the important one is make sure the hypotenuse is your c. So the hypotenuse is the long side across from what you think is the 90-degree angle. So in this case, if the triangle on the left was a right triangle, 3 squared plus 4 squared would have to equal 5 squared. You can put that into your calculator. This ends up being 9 plus 16 is equal to 25. And that is indeed true. 25 is equal to 25. In that case, a squared plus b squared does equal c squared. So this is a right triangle. The triangle on the right, we can check that one as well. Again, the c is the important, that long one has to be on the end. So I can write 3 squared plus 6 squared and see if that's equal to 7 squared. Well, 3 squared is 9, 6 squared is 6 times 6, that's 36. 7 squared is 7 times 7, that's 49. 9 plus 36, that's 45. Oh, 45 is not equal to 49. So none of these actually equal to each other. Since it doesn't work out, since a squared plus b squared does not equal c squared, that is not a right triangle. So one of the uses of the Pythagorean theorem is to actually see if you have a right angle, if this is a right triangle. That's something that's actually can be used a lot in construction. If you want to make sure your doorway has a 90-degree angle, the Pythagorean theorem is one good way to do it. All right. Most of our problems are actually going to have to do with finding missing lengths. So like finding x. In this case, x is that c, it's that long side. So in this case, we would just do 5 squared plus 12 squared equals x squared. And you would just solve to find x. In this case, that's 25 plus 144. 25 plus 144 is 169. If you don't remember, the way to get rid of that squared right there is to do the square root. So I'm going to do the square root of both sides. And the square root of 169 is 13. You can use your calculator for that if you're not sure. But 13 is equal to x. All right. It would be a good idea to pause the video and see if you can do it with this one. I'm going to go ahead and do it right now. For this one, again, y is the one that's across from the 90. So that's my c. That's the one that has to go equal to c squared. So in this case, it'll be 20 squared plus 16 squared equals whatever that y is squared. 20 squared, I know that, that's 400. Plus 16 squared, I'm not so sure of. I'm going to use my calculator for that. 256. So that's 656. Again, to get rid of that 656, you just do the square root. Or to get rid of that square. In this case, it ends up being a decimal. So 25.61 about. And again, the way we got that, to get rid of a squared, you do the square root of both sides. So there's to it. All right, let's try a couple different types of problems. Here's two more. This time you'll note my c, my long side, is over there. So if you were to do this one, I have to have it a squared plus b squared equal to c squared. I have to have that 100 be the c, right? The setup is important. Knowing where that long side is important. So for this one, w squared plus 64 squared equal 100 squared. Then you just do the math some more. W squared plus, that's a big number, 64 squared is 4,096. 100 squared is 10,000. I want to get W by itself, so I'm going to subtract 4096 from both sides. W squared equals 5904. You can see a calculator would probably be useful for this section. And then we take the square root of both sides. About 76.84. All right, that's all this lesson is about. There's one more problem here just for practice. Again, I would recommend you pause the video and give it a shot, but I'm going to do it right now. Again, the one across from the 90 is your C. So that's my equal to c squared. So when I do a squared plus b squared, it's going to be e squared plus 28 squared equals that long side squared, equals 40 squared. And then you just plug some things into your calculator. 28 squared is 784. So e squared plus 784. 40 squared is 1600. I'm going to subtract that 784 from both sides. I get 816. And then last, to get rid of that squared, we're going to do the square root of both sides. 28.57. There it is. All right, your assignment is just to practice these. There's 7 through 11, the odd problems. So that's 7, 9, and 11. 17 through 21, the odd, which would be 17, 19, and 21. And then just 24 and 25. If you need help, you can see me in my office hour. I'll see you next class.